I'm going to output 1, yeah, 1 comma 8. I'm going to output brackets. Okay. But up here, I'm going to output one comma 1. I'm going to output pies. Okay. So oops. So I'm going to go down here. I'm going to select this pawn. Okay. Pies and brackets. And then I'm going to press alpha. Oh, shoot. Okay, I'm going to select this pawn. Then I'm going to erase this. I got to erase these. Okay. Now I'm going to press alpha. Oh, so it never enters that. Well, that's strange. So, what am I missing? What did I miss? How did it... So it doesn't get in that loop. How's it getting negated? How in the world is it getting reset? Wait. Int Q stores Q. So Q is getting set to normal when I press alpha. I'm going through the list of everything that I subtracted 2 from. But I don't negate. I don't fix the value of that of the thing on the matrix there. So how did that get fixed? How in the world did it go back to normal? That doesn't... What? That doesn't make any sense. That's the only place where I negate it. Oh, you know why? It's being outputted. No, the actual value, it's... The actual value when I look at the matrix is, there it's a 1. Now when I press alpha, it should stay, it should have not changed. That is weird. I didn't even press second. That doesn't make any sense. Cuz I'll press second right there. And then I'll end it. And now cuz I didn't press alpha, it'll be negative. But if I press alpha, that it doesn't make any sense. I press it, now I press alpha. Okay? It doesn't print it to the screen. And somehow it negates it. Wait, hold on a second. This doesn't make any sense. Hold on. I'm going to come down here. I'm going to press second. I'm going to erase these pies. Okay, I didn't press alpha. So when I stop it, It should be negative. Yes, it is. Okay. I'm going to do the same thing again. I'm going to come down here. I am going to set it. I'm going to come up here. I'm going to erase these pi's. Okay. But I'm going to press alpha. Nothing printed up there at the top. Nothing printed. Nothing. And yeah, it's positive. That doesn't. Okay, what did I forget? What am I missing? How? I did not negate it. Hold on, I'm insane or something, because this doesn't make any sense. 31. Okay, so if A equals 31, then we change the state of Q. Okay. That's all I did was press alpha. That's all I did. And this is the only thing that happens when I press alpha. This is the only this is the only thing that it does. It changes the state of Q to Q to integer of Q. It doesn't even do this. It doesn't even go in here, because I didn't even press the blue key, so it didn't even touch it. B is 1 to C. So it fixes all the moves that I want it to move to, which were stored in list 1 and list 2. And those were not even, that's not even IJ. That's like, with the pawn, it's IJ minus 1. And there's nowhere else in the code that anything does. I don't even press 21. And these don't even get outputted. Like, this would get outputted. If it reached this line, this line would be reached as well. I don't understand how pressing alpha is setting that to negative. How it's setting it. It's setting it back to positive. I don't understand how that's happening. It just doesn't make sense. It just doesn't make sense. Unless the bees have something to do with it. That would be kind of funny. If D is less than 0, output C. That is the only. That doesn't make any sense. Okay, so what happens if I hit alpha twice? So there's once. There's twice. No, not go to. Is it negated like twice? Is it negated again? No, it's back to normal. How is that possible? I don't understand how this is even. I don't even understand how this is possible. I mean, what? I think it has something to do with the state. That's the only way any of this could be happening, is if the state. I mean, it's the only way any of this could be happening. It's just the only thing that makes sense. I don't negate it. I don't negate oh, and I'm supposed to. And that's the thing. It's getting negated without me even doing anything. It just doesn't make sense. Okay, I'm gonna erase that line when I press so here I'm gonna press the second. There, I pressed it on purpose. I selected it again. It's like there's a ghost thing going on here. It's like working, instead of it not working when it's supposed to, it's working when it's not supposed to. So it's actually not really working because it's not like, I'm not even intending it to do that, which is a weird thing. But the funny thing is, the irony here is that's what I ultimately want it to do. What the heck is going on? Why is that value getting negated? It should not be getting negated. Okay, so if it's not reaching that line though, because it obviously isn't. It can't be reaching this line. It obviously isn't. So let's go back to interesting. Interesting. Now this is strange. It might have to do with the I's and J's because these, I did this wrong. This is supposed to be J minus 1 stores in there, not J, because I'm saving the values of the things that I want to undo. And that's definitely J minus 1. That's a destination area. So that's one reason. But that's weird because I am subtracting 2. From those. Oh no. Oh, you gotta be kidding me. Okay, so this is why I was confused. So this pawn has literally been copying the value of the pawn 2 spaces to the left of it. See, this is the y value, this is the x value, and then I'm subtracting 2 from L1C, not from this entire value. So it stole the value from next to it. I think I need another parentheses right there. Okay. And then since since L1 and L2 were storing my original value, I accidentally stored that instead of the destination. Oh man. That is just the funniest. That is the goofiest. That is a funny mistake. Because that was like weird. That was a weird mistake. Okay, so here's where I'm actually going to negate it. So negative matrix A, J, comma I, store as matrix A, J, comma I. And then we'll erase the outputs. So we'll erase that output. And we'll erase that output. Oops! Wait. Wait. No. 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 That was X. I accidentally erased the wrong line there. Anyway, this up. Okay. So I set it to 1. I press the green button. Should be erased. That one should have gone back to normal though. I don't... Wait. I pressed the green. So something's not right here. Let's see what I and J are. And then let's see what list 1. What? List 2. Okay, let's edit chess. We're gonna delete list 1 and list 2 early on. So let's go ahead and just, because I don't want there to be some kind of weird thing with extra data. I just want to start, whenever we run the program, we start with an empty, just completely empty list. So there's no, so if we have a bug or something, we can track down. It's more deterministic. So let's go ahead and delete. No. I want to edit 0. I want the catalog. Delete var. Catalog again. Delete var. And we'll do list 1. And we'll do list 2. Oops. Yeah, so now it's going to be more deterministic. Here we go. So I'm going to press second. Alpha. Now that is just wrong. That is all wrong. Those should not both be -2s. Yeah, something is amiss here. What am I doing? Okay, so for B is 1 to C. First of all, that's its own loop. Not that it really mattered for that case. Second of all, this, you shouldn't even be able to press alpha twice. So I have to say and, I'll say fractional part of Q. There, that way we can only cancel it if we are in a selection state. So that makes that work. That's a couple things that needed to be fixed. And I don't know. Why is that not showing up? Why is it not showing up? Why is it not showing up? There should be a star there. Four and six. My brain is just turning off. I just don't know what. Okay, so the star should show up here. No, it shouldn't, because I didn't do that. There's the line that I accidentally erased. Okay, that makes sense. Okay, so I and J. Okay, so let's try that. So I press second, it shows up, I walk over it, it's gone. It should not be gone. Let's go down here where we find our star. If P minus F part of P is greater than or equal to 2, then star stores string 1. And I will be right back. I have a phone call. Okay, so this video should only be 12 minutes long because I actually put a pizza in the oven. And I set my phone alarm. So the next ring, it should be the alarm. So I was going to check here to make sure. Oh, what's that 2 doing there? What is that 2 doing there? That 2 is like out of place, isn't it? That is where is that 2 coming from? Is that, did I mess up the chord? Did I do this backwards? You know, I might have switched the X and the Y. Hold on. Let me, that 2 is in a very strange, I might have switched the X and the Y coordinates or something. Because that 2 should not be there. Where do I add 2 to everything? Oh, yep. Hold on. When we use the, yeah, see? Yep. And when we check the matrix, here we go. 1, 5. Yeah, no. Yeah, I switched the X and the Y. That's exactly what I did. Where is it? Where is it? Right here. Look at this. Look at this. It should be J minus 1, comma I. And it should be J minus 1, comma I. Oops. not J, I. So let's go back to chess. So here we go. I press second, that shows up, I go up twice, and it shows up again. Perfect. Okay, now I press alpha. So what's Q here? Hold on, something's wrong with my alpha now. Q is 0. So something just is amiss here. Something's just not adding up. So when I press and F part of Q. So the first time I press alpha, this should function once, because the F part of Q should be something, and then I make it not something, and then I go through the loop and I negate it. Okay, so let me just make sure that my the Q's getting set. So I press second here. Now I'm gonna quit right after I do that, and we'll check what Q is. Q is 0. What? There's our problem. So let's go, and we should be setting our Q to be whatever piece that we have. To at least, yeah, so whatever our piece that we selected is. So if fractional part of P and Q equals int P. Oh, I'm tempted to put the extra safety catch in here, but by saying if the fractional part of Q is nothing, that would like make sure that we wouldn't enter the wrong time. But we probably are okay. I'm too much of an optimal, I'm too much of trying to reduce the code to simplicity. It actually is better to do it that way, but it's kind of hard to do here because there's not, I mean, the best way to do that is like recursive and doing everything functionally. So, but it's not, we don't have like the easily visible space here, and we're not even doing everything with the elegant type of programming, so it's kind of strange. Anyway, matrix A of j minus 1 I plus 2 This, where do we change Q? It should be like right here. Actually, it should be like kind of like right here. So, oh wait, no, that is an int anyway. Yeah, so Q should be set. Whoa, what the? What? We should set Q here. What? No. So matrix A no, we should just be storing P into Q. That's what we should be doing. Because that's essentially, I mean, that's what we're doing, is we're just, Q, our state is essentially the piece that we selected. I mean, that's basically what it is. So, I mean, I don't see why it shouldn't be just P. Okay, so now I move around, I press alpha. Okay, it's okay that nothing changed right now, but if I run over this, it should be deleted. It should be back to the original state. Okay, that's good. Okay, so now I'm going to change it so when you press alpha, those will go away right away, so that we'll just visually erase them as well. So we'll put that in the loop. So where are we? Up more. Oop, down more. Okay, so right here, we need to do that here. So we need to reprint the correct piece in each of the states. So that means we can do, I guess we can do the B for loop. For B is 1 to C. Great. Maybe we'll just do D. For D is 1 to, or negative 1 to 0. And then, and before that, we're going to store, you know, we might as well store them up here anyway. Oops. Because it'll take us less computation time. Because TI basic takes forever to get these variables. And what were our variables? N and O, right? So O is the Y, and N was the X. Okay, so we're going to do O here instead of accessing this again. Just do O. And then N will go here. Yep. And then we're going to, this is going to be O. And then this will be N. Okay. Yeah, that seems like it'll work. And then we have them stored for this. So we're going to call our subroutine for D is negative 1 to 0. And we're going to call oh, we got to set P. We got to set P. So you know what I'm going to do? I'm going to store this one into P. Like that. And then I'll set P as the new matrix thing. And then P, O, and N will be set for the subroutine. They'll come back. I'll have string 1. So if D then I go to 0. Okay. So if D, then I go to 0. So when it's negative 1, it does the subroutine. And then I output the string. Oh. Now my pizza's, I think my pizza's done. So I'm going to output ON string 1. And then for here, I'm going to output geez, what am I going to what am I going to put? Because I want to rewrite, or I don't want to I might have to do the JI. Yeah, you know what? I'll probably have to call the subroutine again to rewrite the other one. So, since that'll take more than a minute, I gotta go grab my pizza so it doesn't burn, and I'll be back. Okay, I'm back. You guys, I wish you could see the setup here. I have like, my camera is attached to the top of a 100% cranberry juice container. That's actually full of cranberry juice, by the way. And then it's sitting on top of a math book that's sticking out from a stack of books, like some engineering books and stuff. And then it has like a law book that's weighting down the other side so that it can stick out without falling. And now I have on top of the law book, there's a whole pizza that's like sticking off the edges of the plate that it's on. And it's really hot, so I'm trying not to burn myself. So I'll be eating this pizza. Hope you don't mind. Oh yeah, so we're going to store J into 0. I mean to O, sorry. I mean I into N, because we're going to, I think I'm going to just call this subroutine for this. Which means we just store this into P. And then we store P into there, and then what we do is we will need the output. And it will need to be J 2i minus 1 string 1. And by the way, is that what I did up here? I think it's supposed to be O and then 2n minus 1 string 1. So hold on, so I store P and O and N. Let's call the subroutine with D. So for D is -1 to 0, if D go to 0 and then we output string 1 there. Okay, so let's see if it works. So I come down here, I press second, the 1 works, I should be far away, and then if I press alpha, they should both go away. Oh man, it worked! That is so cool. Okay, nice. I press alpha, and they go away. Okay. That is cool. There is the issue that that's not getting erased for some reason. Oh, and it's being a star minus. I don't know why it's doing star minus. It shouldn't be doing star minus. Oh, I know why. Because usually, okay, so this is in the subroutine for erasing ourselves. I'm gonna eat some more of this pizza. So I store star into string 1. Hmm. Hmm. P equals 0 means there's no piece there. So that means we output the grid, which means P is actually going to equal 2. Hmm. So we need to separate that because... So it doesn't matter which branch we do it in. I'll just put it in this first branch, but it's like its own type of case thing. But we either need to... Either way, it's not printing, so it's the way it is right now, it won't print. If there's nothing there, but it's like a designated target piece, or a target spot, it won't print both characters. Which I need it to do when it's the empty spot. Okay, so if P equals 2, then I'm going to do that. Else we have that. I'll say if P equals 2, then it's space and then brackets. Or not brackets, it's star then space. Sorry. Store as string 1. Okay, so that should work. So now the output should still look just as good. Yep. So when I erase it, it should... Why does it have the minus? No. That's 2 there, isn't it? It's a 2. Yes, it's a 2, see? It's a 2. So why is it... Why is that not working? I gotta go all the way to the bottom now. It just doesn't make sense. I just don't understand. Oh yeah, yeah, yeah. Or P equals 2. Yep, that's it. That should work. Yep. Okay. Nice. Okay, now we can move on to adding in more let's make it so we can actually move the pawn, because it'll be easier for us to test. Okay, so I'll be able to press second. Okay, so I should only be able to press second if the value is greater than 2. Right? Ow, this is hot. Okay. So I think it would be right. I think it's here, because this is the outer loop. This is if A equals 21. And this is, so that means this gets executed. Okay, so that means this pizza's so good. I must have been hungry or something. Can I mess with P? Or what? No, P will get messed with. Okay. So we'll have to do this independently. Anyway. Okay, so yeah, so if matrix A yx is greater than or equal to 2, then that means we have a valid changing. Not only, okay, so that means we have a valid move change. And we have a change of team. So this is the branch where the most change takes place, because we're making a move, we're changing teams, we're moving the piece. We're changing the state, what we're in. By the way, if we were writing this chess in like Java or something, we'd be done by now. This is so much easier than an actual programming language that you can edit freely and easily and has functions. Just saying. Anyway. If it's greater than 2, we need to move the piece. So we need to take piece ij. No, we just need to store a 0. It is ji, my bad. So matrix A we're going to move our old piece to our current location. We're going to set our old place as 0. We're going to correct the states. And then we're going to redraw the screen. Or we're going to redraw those two positions. So we're going to store x into n and y into o. And we're going to do that loop thing. So for d is -1 to 0. If d label label 0, end. And we'll just do the same thing again for I and j. X stores n, so I stores n, j store is o. For d is -1 to 0. If d go to zero, and of course matrix A, O, N stores P for that as well. And not label 0, I'm sorry, this is go to 0. That would have messed everything. And I'm getting a phone call. Be right back. And we're back. So I'm trying to remember what we were doing. Oh yeah, we're moving the piece, so we want to output I think I was about to test it. So let's try to move this pawn to here. Whoa. Did I actually move the piece? I think I moved the piece. Which means I should not be able to move these pieces anymore. I should be able to move just these pieces. Which there are no moves for this piece, so I'll have to cancel. Nice. So that actually worked. Wow. Nice. Nice, nice. Okay, so I can move a pawn. And how many hours in is this before I move a pawn? It's pretty far in. But at least I could move one, so that's good. There was an issue though. There was an issue. Let's go back and do this again. Okay, if I try to move there, it shouldn't work. But if I try to move here, did it work? No, see, it's not erasing this piece. And there shouldn't be a 1 there. Why is there a 1 there? Huh. There shouldn't be, let's see, what's Q? Q is 1, and then C is 1. I don't know why my camera does this. I don't know, Sony. Fix it. I would be very happy to do product placement, but until you fix your cameras, you suck! By the way, everyone, Sony made this camera with the changing zoom. Zoom. Sony's the one who did that. Good job, Sony. Your camera didn't go through enough testing. You don't know how bad it is. Somebody put a little bug in it. Okay. So matrix alpha 0 to p, x and y. We don't need to show x and y, so I can actually delete this entire section right here, because when I move, it'll correct anyway, because the cursor is going to be over top of it anyway. Okay, but we do want to move the piece that was moved. We do want to correct the display there. So d is -1 to 0. If d go to 0, matrix A ON stores P. So it should be 0 because I store it into JI. J is the Y value. Yeah, so this should be 0. In fact, I shouldn't even have to, I mean, I should just 0 stores P. It's always going to be 0 anyway. I don't know why I was like getting the value. So when I move the piece, okay, it changes to plus, and it should have erased the 1p. Why is it displaying it again? Oh, you know what? It thinks... Okay, so there's an issue with... Let's see here. Q is 1. So where does it actually output the C value? That's what's not getting fixed. It's right here. See, if D is less than 0, P stores D. Oh. You know what? I know why. We never fixed it, that's why. I forgot to change one thing. So let's see here. If I move this piece to here, and let's quit, and let's look at matrix A, I bet you it's going to be negative. Bingo! So that's our issue. So I forgot to change, so I need to negate it. It's as simple as that. Oh wow, this, I can't believe this is working so well. So we need to negate. Notice how we're like, look, int Q stores Q, not Q stores Q. Move this piece, 0 stores the old place. Now we're gonna negate it. Okay, so we need to negate. Oh, I'll be right back. Okay, welcome back. Looks like this project is going to take more than just an evening, so here we go on the next day. I think what we left off, we had just gotten this to work. Let's try moving this pawn again. Okay, if I move the pawn there, it should update the old spot. So we kind of have an issue updating the old spot. Let's go ahead and find where was the code to call the subroutine to update the old spot after we moved. It's at the end of our wait. This is it right here. Okay. Yeah, so something is not right here. Because 0 is set as P, and I and J are the old position. So for D is -1 to 0, if D go to 0, so we definitely, looks like we called the subroutine here. Oh, I know why. Derpity derp. Because we don't have an output. That's why. So output J, I, and then string 1. And that, I think, yeah, that should be wait, what? Oh, J and 2I minus 1. My bad. My mistake. Let's go back down there and fix it. Where is it? There it is. J, 2I minus 1. There we go. We come down here, we select, we move, and the piece is erased. Okay. So, wait, what? Why is there a 1 there? Oh, I was trying to fix that, wasn't I? Something's wrong with when you walk over the old piece, it wasn't getting negated or something. Yeah, so I think, hold on, let's check out matrix A. Yeah, we didn't fix that, apparently. I thought I found the problem, I guess I just haven't fixed it yet. We need to negate, we just simply need to negate the number. Because the state gets updated, we just need to negate the value there. So we put negative of that into our move. So let's go to chess, and we'll try this one more time. So I'm going to come down here, I'm going to select it, I'm going to move the pawn up, he moves, and he's correctly moved, and I'm correctly in the plus state. Alright. So we actually, okay, now we finally officially have the pawn, one piece moving correctly as expected. So it is time for us to move on. There's nothing more for us to debug here. We're going to add more pieces to be able to be moved. So here we go. Let's go ahead and make the enemy pawn be able to move. So if j plus 1, okay, because we're moving down, is less than or equal to 8, because the maximum when we're moving down is obviously down, then, and do we need a, I'm going to put an end here. Oh, you know what we should do? We should make a subroutine. Oh, this is going to be kind of tricky, but I have an idea. Essentially, what we can do is we can make a subroutine. Ooh, and this subroutine might get called by a subroutine that I'll make in the future. Okay, so this is going to be a little tricky. But we have to move all this code down because I'm going to make all these branches for all the pieces. And I want to essentially, I want to be able to just kind of give the coordinates and specify like what places to add if possible. It'll automatically check. See, I'm going to make the subroutine automatically check to see if the piece is valid. Oh, you know what? No, I won't make the subroutine for this because I want to make the subroutine check to see if we're running over an enemy piece. And for the pawn, we're not doing that for the moving forward part. So actually, we won't call the subroutine here. But when we do the attack move, what we're going to do is we're going to set like two variables, like N and O or something like that. And we're going to actually like we're actually going to like call the subroutine and have it added using the subroutine. So it'll be really simple to just say like, here, these are the moves that you can attack to. But since the pawn is different, we want to give it the option of, yeah, we want to give it the option. So if j plus 1 is less than 8, then what do we do down here? Oh, we want to make sure there's no fractional part of that position. Okay. Okay. So if not fractional part of matrix A, j plus 1 I. Okay, then what do we do? Oops. Oh, wow. Wow, I thought it was moving, or I thought it was working correctly, but you know what? J minus 1 I. I was just lucky that I wasn't lucky, but it just happened to work correctly because it was still selecting a piece that, yeah, so I had those coordinates mixed up, but that's okay because I fixed it. Then c plus 1 equals store c. So here we go. C plus 1 store is c. Okay, and then we're going to add 2 to it, and then we're going to output, let's see here. Yeah, we're going to add 2 to it, and then we're going to output it with a star, and then we're going to store it into list 1 and list 2. Yep. Okay, so add 2 to it, output it. So matrix A, j plus 1, comma I, plus 2, store into matrix A, j plus 1, comma I, and then we're going to store into list 1 and list 2. I, j plus 1, okay, and then we also have to output it, so output j plus 1, comma 2I minus 1, comma star. I think that's what I'm supposed to do. Yeah, so let's go ahead and test this chess. Okay, so here's where we can actually test to see if the turning works. Okay, so I moved white. I shouldn't be able to select a piece here. I should be able to select this piece. Yes, I can move it here. Good, it correctly moved. Okay, now I should not be able to select that piece again. Good. But I should be able to move this piece up. Yep. Okay, and then I should be able to move this piece down. And then I should not be able to move this piece up. Yep, I can't. So I'm going to take this piece, or I'm going to cancel. Okay, I'm going to take this piece and I'm going to move it up. And then I should not be able to move this piece down. Yep. Woo, it's working. Alright, we got some chess going on here. All we can do is move pawns forward one piece, though. That's the only thing we can do. But it's working. It's correctly changing state. Alright, let's do this. Alright, so the green button, we'll just use that as cancel. If we picked up a piece and we don't actually want to move it, you just press the green button. And then it'll put down the piece essentially. So let's see here. Oh, I can't move that because I got to move a plus piece now. Alright, we're getting close. We're getting close. I am actually excited because if I finish this, I might go and play it with my little sister because I'll be able to visit home this spring break this week. So we might play a little chess with each other. Who knows? But there's still a lot more to do because we still have to actually check. We do have to actually check. Believe it or not, we have to decide if we have to check if the enemy, if we're not questioning the moves of the king, if we're not threatening our own king. We have to actually check that, which is kind of a crazy thing to check because essentially we have to go through the entire, enemies list, and since there's only 64 pieces on the board, we might as well just look through the entire board, and for every enemy piece, we have to see if it can attack our king after that move. So that might take a long time. What I could do, since I do want this to run fairly quickly, is I could do the check when you actually move, rather than to see where you can move. I can actually change it so that it just checks it when you want to move there, and it'll tell you. But the problem with that is then the game won't automatically tell you when you have checkmate. So yeah, that's kind of difficult. It's kind of difficult to work with that, but it'd be okay, maybe. What I could do is I could just leave the board. I could just kind of make like a chess that doesn't have the full game built into it. You know, it doesn't check for checkmate, and it doesn't have any check protection for your king. And it wouldn't be like a full, chess game, but it would still be playable. You would just have to, both you and your opponent would just have to follow the rules that you can't, put your own king in check or something like that. And usually chess is played, with pieces anyway, so yeah, because I'm thinking it'll run too slowly, so we might not actually end up doing that. We might end up just kind of showing where you can move in general. So, because if you put yourself into check, that's kind of like, you notice that your opponent's going to kind of tell you, like, hey, you can't do that, because that's his goal anyways, put you into checkmate. So, I don't know. We could technically do it, but it would run, with the way I programmed it here, it might run really, really slowly to check. Although I do have a theory that maybe you could go through all your pieces and you could see all their attack positions. And this is kind of crazy, but every piece could kind of like mark in the map all its attack positions. But the problem with that is then you'd have to keep track, for every square, you'd have to keep track of which pieces can attack it. Because as soon as you move a piece, how do you know whether you can unmark a spot? Unless maybe you just kept track of some kind of stack, so some kind of counter for every square on the board. You could keep some kind of counter that would count how many total pieces can attack there. And every time you move a piece, the only things you have to update is all the places where you used to be able to attack, you'd have to reduce them by 1. And all the new places that you can attack, you would increase them by 1. And then that way, to be able to check to see if you'd be putting your king into check would actually be pretty easy, because it would be built into the chessboard already. So I think that would work for as far as speed. But to do it, I don't know. I might even like assign another matrix so that we use like matrix B and matrix C or something, just to make it easier on decoding, because otherwise we're going to have some kind of like number that's going to represent like 20 different things, and it's going to be insane. You don't want to have a counter that's like, multiply, divide by 64, divide by 64 again. And you could do that technically. Since there are a constant number of spaces on the board, we could store all the information into one matrix, one set of integers. But if we want to keep the code simple, we might as well, use matrix B and matrix C as well. So yeah, I think this is possible. but it's going to be annoying to program, because writing, I mean, it's going to be hard. So that means every time you move a piece, well, no, because the problem with that is when you move a piece, you're also altering the other pieces around you in whether they can attack certain places, like rooks and things like that. So the problem is you could be blocking a queen, and then if you unblock the queen, okay, now the queen used to not be able to attack those spots. Yeah, okay, never mind. That idea wouldn't really work as simply as I put it. I don't know if you could get a stack kind of idea to work, but you'd have to somehow build it into the the queen and the bishop and the rooks. Like you'd have to check all the queens, bishops, and rooks on the board. Because the other pieces, you would just check if you were in range of them, but the queens, bishops, and rooks, you'd have to check if you were blocking them. And just update those, I suppose. And if you're going to update those, I mean, you might as well just search the entire board every time. It's not worth trying to reduce the computation. You might as well just deal with doing the check, because that would just be ridiculous. That would be kind of ridiculous to do that. Yeah, getting these games to fit on this calculator is just kind of, sometimes it just seems kind of crazy to do it all in BASIC. I mean, in assembly it probably would be just fine, but if you could organize it that way. But man, writing it in this is crazy. It's just crazy. Yeah, so I'm gonna do, okay, so I'm gonna do this. I'm gonna do label 1, and okay, so what this is gonna be is this is just attack subroutine. So if I want to attack, this is what's gonna be available. So if I want to consider a piece that to be attacking, it's going to be there. So let's go up here. Okay, this is where we select our pawn. We want our pawn to attack to the right and to the left. Might as well do the white pawn first, since we did his moving first. And let's see here, if j is greater than or equal to 1, okay, so here's where we separate. So okay, so inside here is 0, we don't want to deal with it. Inside here is 1. We're in the black piece selection. Inside here is 2. We're going to be able to move down. Oh, we'll put this in 2. Yeah. In fact, we're going to put it right here after we add the moving down one, because j plus 1 will have to be less than or equal to 8. So if not fractional part of A, yep. Okay, so excuse me. So what I want to do is I want to minimize it. So it always will be the same as far as teams go. So we can just read our team in the subroutine from Q. Okay, and then so we don't need to check that. All we need to do is all we really need to do is just actually we don't even need to put it inside of this one, but we will. Because we already checked if j was less than 8. But we actually won't need to check that because we're going to check all that in the subroutine for every attack position anyway. So we're going to call the subroutine. And we're going to pass it coordinates. And I think that's it. I think we just pass it coordinates. Right? I mean, do we need anything else other than coordinates? I mean, that's it, right? I think that's it. I seriously think that's all we have to do. And this is the beauty of programming, is this is going to be so easy for us that you probably don't even realize how easily I'm about to add all the pieces' attack moves. Like every piece in the game, I'm about to add their attack moves with ease by making this subroutine. So let's go ahead and add the black ones. So what we're going to do is we're going to have let's see, j plus 1 is going to be our O, and I plus 1 is going to be our N, right? Because we're looking to the right and we're looking to the left. So j plus 1 is going to be our O again, and then I minus 1 is going to be our N for the second one. And so we're just going to do a subroutine call. So we're just going to do for D is -1 to 0. If D go to 1. Okay, so for D is -1 to 0. If D go to 1. Okay, so now we need to include all the logic. We need to include all the logic, and we need to print to the screen. We need to do everything in the subroutine, but this is going to make it so easy. This is going to make it awesomely easy. Okay, so here is our subroutine. We have the coordinates N and O, and we check if, then, end. Okay, this is where we check everything. Okay, we check the N to see if N is greater than or equal to 0, and N is less than or equal to 8, and O is greater than or equal to 0, and O is less than or equal to 8. Okay, so that means anytime we're going to do this check, we checked right there to see if it's on the board. If it's not on the board, it won't get in here. So there's our check to see if it's on the board. Now, we're going to take integer of Q, we're going to store it as P, because we can use P, because P is used as a subroutine kind of passing variable. So, and I don't think we're going to call, well, actually we might call a subroutine from here. We can't use D because D is used to call. Okay, so int Q stores P. This is going to tell us which team we're on. And then we want to store, or you know what? Let's just use a new variable. E is going to be the state that we're in the subroutine. Okay, it's going to tell us like what team we are. Okay, and the piece, okay, so we're going to take matrix A of O, N, okay, and we're going to store that into P. So that tells us which piece we are looking at. Okay. And we want to check one more thing. We want to make sure that the pieces are enemy. So we want to make sure that the integer P is equal to not E, right? Or not, well, you know what? We might be able to not have to deal with E. I might be able to just put Q here like that, and that'll be okay. Yeah, so we only get in here if the piece we're attacking is in fact an enemy piece. Okay, so notice how I've done all the checks here for attacking. Okay. Now let's go up here and we have to make sure we include everything we're supposed to include for moving the piece. So we're going to put a 0 in our old coordinates. Oh, you know what? I think that's the part that I forgot to pass down, is the old coordinates. Oh, but you know what? The old coordinates are going to be in J and I. So those are, yeah, that'll work. J and I will hold the old coordinates. In fact, since, here, I'll show you on here. Notice how P is what I'm using to define what's at O and N. That means I might as well use K to define what's at I and J. So I'll just, when I'm in the subroutine, I'll use K for the old piece. That should work. Where am I? Yeah, so if you see here, I say go to 1, but J and I are still the correct original piece. So that means down here at the subroutine, I can make if P equals not in Q. Okay, that means it's the correct team. That means I can take matrix A of Ji, and I'm going to store that into K. And now I got P and K to deal with here. So we're going to store 0 into that matrix. because we saved the value anyway, so we don't need to touch it anymore. Although we do want to because we do want to update. We do need to update it. We don't need to update where we're attacking because the cursor is expected to be there. Right? Isn't it? Oh no, it's not. The cursor is expected to be on the piece that we selected. So yeah, we don't need to deal with that anymore. But we do need to deal with the piece, the NO piece. We need to update. We need to call the subroutine. I wonder if you can go to a place that's previous to your position. I think you can. I think you can. I think you definitely should be able to do that. If you can't, then I'm screwed myself by making this subroutine beneath the other subroutine. Because the other subroutine definitely doesn't need this one, since all it does is print. So I need to add. I need to invert Q. Right? I think so. Right? No, wait. Hold on. This is not the attacking. This is not the attacking subroutine. This is the find out if I can move there subroutine. That's what it is. Right? Yeah, I think. Yeah. My bad. What am I doing? I'm not changing states because I'm not attacking. Okay. Whew. So I need to set the new value to 2. So the new value is P. So P plus 2, store as matrix A. Why am I doing this with the old value? Hold on a second. All I'm doing is I'm updating the attack position. Okay? So I don't need to do this. I don't even know if I need to do this. I don't know why I did that. All I'm doing is updating it. So that means I just need to add 2 to the matrix and then update it. Right? Isn't that all I need to do? I mean, isn't it? Isn't that all I need to do? Oh, it's not just attacking though. It's okay, hold on a second. It's moving or attacking. Hold on though. Okay. I forgot, the pawn can only move sideways only if it is attacking, but the other pieces, it doesn't have to be attacking. So I can still call the subroutine, but I have to put it inside a branch in the pawn that says that, you know, there actually is a non-zero piece there. So as long as it's non-zero, then I can put it through the subroutine test, and the subroutine will see if, well, then, you know, see if it's a valid move, but it just won't ever occur if the piece is blank space. So let's see, p plus 2. So that means, hold on. So either int p equals not int q. The only problem with this is if I take the int of one team, it might make it look as though the space is empty. So I have to do either that is true and there's a piece there. So I'll say and fractional part of p, or we can just say not p. Because if p is 0, then it's a blank spot and we're good to go. If it's fractional part, then we check not int q. Then we check to make sure it's on the opposite team. So if there's a piece there, it has to be on the opposite team. If there's no piece there, then we're good. But it has to satisfy one of those two conditions. And then we add one to A, and then I want to see if this, I think this will work, because when you call the subroutine and p is 2, yes, then, okay, so here we're going to call the other subroutine. So for e, I guess, is -1 to 0. Okay, I'll be right back. Okay, welcome back. Okay, so I think I kind of made a decision about something, and I'm not sure if I'm just going to stick with this or if I'm going to... But this is what I'm thinking. So I'm thinking of just posting this once I'm done making it so that we can move all the pieces without the check system. And we'll leave that up to the players to do. And what I'll do is I'll post the video and I'll just mention with the video that I kind of only, I mean, what it does is limited. And if somebody requests that I complete a full version, if I get enough requesting for that, then I'll work on it. But I mean, if it's not like that big of a deal, and if the viewers are satisfied with basically what I'll have set up, which is just kind of like the game without the check for the king, then we'll just stick with that. We don't really have to go, we don't have to do this, you know, all the way, because it is kind of hard to put a full chess game, and it will kind of run slowly on here. But it does kind of open up my mind to see how complex, you know, how complex code can get and how hard it can be to manage code that's not, you know, it's not functional, it's not very easy to write subroutines, it's not very, there's not a lot of space on the screen to see what's going on. So it is kind of, you know, just giving me kind of a view of, you know, what that's like for a really big program, because it is kind of hard. It gets kind of difficult to keep track of what's going on when you can't really indent and things like that. So let's just try to finish the moves, and then we'll just kind of put it at a stop for there, and we'll just like say, you know, I can probably rename it, you know, episode 1 or something, if there ends up being more episodes. But if we just leave it at this, maybe that'll be enough. I guess maybe, you know, I could have done better, who knows. I haven't looked at other chess programs online. Somebody might have made, you know, a full all-out one, or somebody might have already made like a, you know, an assembly version or something that works really well, and one that uses pictures and stuff, and symbols. So yeah, that might be a good place to stop, you know, just for my situation, for my skills, and for how for the fact that we're sticking to basic here, things like that. So although chess is not too difficult to program in like a higher level language, object oriented and things like that, it is sort of difficult, you know, in TI basic world. But I did want to do it, so we are going to try to finish this. So one thing that I need to do here is make sure that when I call the subroutine to add the attacking moves, we need to make sure that they don't get called unless we actually can attack another piece. So let's go ahead and let's just so it says we have 1, which is interesting because I thought I programmed it to check both ways. Oh, you know what? That was only for the plus, wasn't it? For the black. Oh no, wait. Oh, here we go. Okay. There we go. Okay, so that was not... Uh-oh. Uh-oh. Okay, so let me guess. I might be able to move this P over here. Yep. Okay, so there's a couple of bugs, but... And hold on, I should be able to take this guy and move him all the way over here. Yep. Okay, so the reason why that is because I'm not correctly deactivating. So when I move, I need to go through the list, and I need to change all the things with 2s to not be 2s. And I also need to display where I can move. And then once we get all those bugs out of there, then I have to alter the code for attacking to make sure that it only works if there's a piece there. I only call that if there's a piece there, not if there's an empty piece, because for the pawn you can only attack diagonally if there actually is an enemy piece there. So yeah, we need to make a few of those changes. Okay, so here's all our checks and everything. We add 2 to P for each of the C's. But we also want to, we add P, and then we do for E is -1 to 0 if E go to 0. So it should have worked. I don't know why it wouldn't have worked. If it's 2, right? Yeah, that should have, okay, so if I move here, okay, so I don't think it's, hold on. If I move this down, okay. Okay. So it did get the piece. Okay, so let's move this pawn here, and then let's go back up to this pawn again. And for some reason, it's updating the piece under him, but not the pieces to the side. It's not drawing those right away, and that's what's confusing me. I'm not sure why that's happening. Let me think about this. Okay. So it does come, it should be coming here. Because I'm adding 2 to P and then I'm setting the matrix there. Okay. And then I don't know if E go to 0. Well, it didn't crash or anything, so it must have found 0. Which, hopefully it did. I mean, I don't understand why they wouldn't show up, though. See, P equals 2. Oh! I'm sorry. This is my fault. My fault. I'm not paying attention. This is the same exact mistake that I made before. This is exactly the same mistake I had before. I'm not outputting this string, so I need to output it O and then 2n minus 1 string 1. Okay, this should work. This should work. So I come here, I move the pawn up, I come here, I select to move the pawn down. See? And so you can see all 3 moves. Now those are incorrect. I know those are incorrect because there has to be a piece there. So we're going to fix that really quick, really easily. It's going to be a really easy fix. So let's go down to the pawn logic. Here we go. If j plus 1 is less than or equal to a, if not f part a, blah, blah, blah. And then here. So j plus 1. So here's one that we just have to do an if statement around. So if, oops, let's go ahead and do that in here. So if matrix A